had a little trouble with the browser, so I apologize for being a couple minutes late. But let's go ahead and get started. We're going to go over the beginning sections in Chapter 2, or Cycle 2 actually called in your book. And the first one's called It's All Relative. And it's on page 150 in your book. And this section's dealing with negative numbers and also absolute values. So let's take a look at what they're talking about. So negative numbers can seem abstract because we can't see -3 apples. But there are situations where we want to use negative numbers. So things like debt, if you're going down, if you're a diver and you went down into the Gulf of Mexico, we would say you went down so many feet and we would use a negative number. So let's talk about the kinds of numbers that you might use for each of these types of situations. So how many cars are in the parking lot? What kind of numbers would we use to describe that? What kind of numbers? So how many cars could be in the parking lot? We can't have negative cars, right? We can have positive, right? But we can also have a 0. So we actually want to look at whole numbers. And we're not using counting numbers because counting numbers start at 1, but we'd actually whole numbers because there might be no cars in the parking lot. So we want to think about that. How about the depth of a submarine if it's descending at a rate of 200 feet per hour? So this is what I mentioned before. What kind of numbers would we use to describe a descending rate? So in other words, the submarine's going under the ocean, so we would use what? Negative numbers. Right, John got it. Negative numbers. Good. And I purchase a candy bar and I plan to share it with my friends. How much will each person get? So what kind of numbers am I using now? So I only have one candy bar. So what kind of numbers am I going to use to describe that? Yeah, I could use fractions or I could use decimals, either one. And then how about this one? Jake uses a spreadsheet to keep track of his finances. He lists purchases, bills, and income, and how much money does he have left after paying his bills? What kind of numbers would Jake use in that spreadsheet? So he could really use all kinds of numbers, right? Yeah, positives and negatives, and he probably also uses some decimals, right? Because, actually I should take positive too, but he also could use decimals because we're talking about money, so we usually have dollars and cents. So let's just look at sign numbers, and your book talks about the sign number having two characteristics. The sign, positive or negative, and then the size of the number. So the size is how far is the number from 0 on the number line. And that's really what we call the absolute value. So -5, for instance, is 5 units from 0 on the negative side. The sign tells us the direction to go on the number line. So notice here, absolute value, we use those vertical bars. The numbers with same size but opposite signs are called opposites. And if we add opposites together, we get 0. So -5, the opposite of -5 would be 5. And the opposite of 17 would be -17. And the set of whole numbers together with their opposites form a set called the integers. So if you remember on that slide before, we talked about counting numbers, which start at 1. The whole numbers start at 0. And the integers are all of the positive and negative numbers. Integers. Okay, just the whole numbers, so positive and negative. So let's try a couple problems. What's the opposite of 8? Anybody want to try that one? What's the opposite of 8? Yeah, positive 8. Good. Find the absolute value of -11. So what's the absolute value of -11? That's 11, right. It's the distance from 0. Good. What is the sign of 24 and what is the size? What's the sign of 24? Remember, by sign, we meant, is it positive or negative? This is positive, and the size is 24, right? Good. Okay, and notice when the sign is positive, we really usually don't put a positive in front of it. It's implied. If it's negative, we're definitely going to put the negative sign in front of it. Read and simplify. So how about this here? How would you simplify this? It says negative, parenthesis, -6. What does that simplify to? Yeah, 6, good. And then how about this one? negative absolute value of negative 6. What does that simplify to? The negative of the absolute, so first of all, work here, because absolute value is like parentheses. So what's the absolute value of negative 6? Is 6, and then Cress is right. Then you apply the negative on the outside. Yep, so that simplifies to negative 6. Good. So just a couple other comments on negative and positive numbers. Sometimes we use different ways to show these. On spreadsheets, a lot of times negative numbers will show up in red, or sometimes they'll be in parentheses, and then the positive numbers are in black. So there's different ways to show positives and negatives. So mathematically, a negative number has a negative sign in front of it. And I mentioned this before. How do we indicate that a number is positive? We can put the positive sign or no sign. So if you just see a number with no sign in front of it, you'll assume that it's a positive number. Is 0 positive or negative? How about 0? Positive or negative? Very good, Robin. It's neither. That's correct. It doesn't have a sign. Remember that number line we had on the prior slide. 0 sits right in the middle. And that's kind of where you start when you're doing plotting and finding things on a number line. You start at 0. It doesn't have a sign. The following examples do not use negative numbers, but each one has a positive or negative meaning. To determine if the meaning is positive or negative. So if I say 100 feet below sea level, is that a positive or a negative number? And then how would I write it? So it doesn't have a sign in it right now. It just has words describing it. And we have the number, we have the size. But what would we write if we were going to describe it? Yep, negative 100. Absolutely. It's a negative number because we're going below sea level. $500 in the black. And this is where you talk about financial. So think of black always means a positive and red always means a negative on a spreadsheet. So this would be, yeah, positive 500. Absolutely. All right, so that's all they did in that section, but we continue with the sign, numbers, operations in the next two sections. So these three all go together pretty nicely. And they use a nice example in here in this section talking about playing golf. I don't know if any of you play golf, but when you play golf, a good player is going to complete the course in try to aim for what's called par. And par is the scores for each hole, and that's what a good player should get. So scores in golf are expressed as some number either greater or less than the par. So assume that a golfer has golfed 2 under par on 3 holes, 3 over par on 3 holes, and 1 under par on 3 holes. If the par for this game is, this 9-hole course is 32, how many strokes did it take the golfer to complete the course? All right, so let's take a look. So 3 holes. Let's get his score relative to par. So on 3 holes, he was 2 under. Notice it said, let me get my trusty little pen here. Assume that he had golfed 2 under par on 3 holes. So by under here, we're going to mean a negative. So if, for instance, if the par is 4 and you get that hole, you get the ball into the hole in 2, you were 2 under par. That's good. It's good to be under par. So on those 3 holes, he has a total of -6 against par. And then he did, let's see, what was his next one? He did 3 over par on 3 holes. So 3 holes, 3 over, so 3 times 3 is 9. And then had 1 under par on 3 holes. 1 under, so there should have been -3. So let's add these numbers up. So what do we have relative to par? His par is 32. Yeah, we get a 0. So his score was 32. He made par. The way you'll hear them talk about it is this golfer made par. And actually, I just noticed this should have a -1 in front of it. We multiplied it correctly, but the -1 wasn't there. So this golfer is right on par. So this is a place where negative numbers are used, sign numbers are used. So there's many times we use negative numbers, and instead of starting with the numbers and performing the computations, let's start with situations and interpret them. And we'll do this to find the result and then learn about notation for the computation. So let's take And sometimes a number line is really helpful. So let's look at this problem. It is currently 5 degrees below zero, but it's supposed to drop 4 more degrees in the next hour. What will the temperature be then? So you want to picture this on a number line. I'm going to try to draw this on here. It's a little bit hard to do. You guys have this in your book too. He's got a -9. Very good, John. So let's see. You started here. And again, it's easier for you guys to do this in your books. At -5. And then what did it say? It dropped 4 more. So you're going to go 4 more drop. And John's right. You end up at -9. Okay? And then how about this one? The stock market has already lost 12 points for the day, but in the next hour it drops 42.68 points more. How far? What's the total loss so far? So it's already at -12. And then it dropped. He's got it, right? I'm going to type this number in because it's too hard to write it all out. And then we went another -42.68. Hold on a second, John. I think it should be -54 instead of 57. See that? -42.68, and then you're going to add the -12. So actually -54. So let me type that down here. Oops. -54.68. Okay, John, you see that? Instead of 57, we want to have 54. Oh, that's okay. No, I'm glad you're working along with them. Oh, I'm sorry. It was Robin. I'm sorry. You're both in purple. That's why. Usually puts you up on the screen with different colors, but your names are both in purple for some reason. Sorry. So subtracting a number is the same thing as adding its opposite. So for instance, A minus B is equal to A plus -B. So for instance, if we wanted to take 10 minus 18, it's the same thing as 10 plus -18. So this is a way to look at subtraction. And especially when the number you're subtracting is larger than the number you're subtracting from, because students tend to have a little trouble with those problems. If you're doing something like 10 minus 5, that's pretty easy to do. But when the number you're subtracting is larger, it sometimes gets a little confusing. So if you can remember this rule, that might help you. So each of the problems in, let's see. So here's some, let me look where I'm at. Let's see here. Oh, the two that we just did, that's right. So we started at a negative number and then we decreased it even more. So this was the temperature and this was the money. So what's the rule? So when we're adding two numbers with the same sign, what do? We keep the sign. We add the numbers and keep the sign. Okay, because all these numbers here they were the same sign, so we added them. 5 plus 4 is 9, and we kept the sign. 12 plus 42.68, and we kept the sign. What about when we add two positive numbers? Same thing. So if I was adding 5 plus 7, and you probably do this without even thinking about it. 5 plus 7 is 12, and you add the numbers and keep the sign. Oops. Should be an equals. 5 plus 7 equals 12. So to add two numbers with the same sign, add the sizes and keep the sign. And here's a couple examples. Negative 15 plus negative 40. 15 plus 40 is 55, and keep the sign. All right, let's try a couple other ones. It's 34 degrees below zero, but the temperature will increase 12 degrees throughout the day. What will the temperature be at the end of the day? So right now, I'm going to type instead. It's negative 34. And it's increasing 12 degrees. So where do we end up now? Negative 22, yeah. Okay. And then this one said the stock market lost 100 points in the first hour of trading but gained 450 throughout the day. What was the net effect? Okay, so it started at negative 100, and then it went up was it 450? So we ended up at, Caressa's right, we ended up at positive 350. Great. All right. Both problems can be written with an addition sign, but the computation you're actually doing is subtracting, right? Right? Because to get from here to here, you subtracted the 12. To get from here to here, you subtracted the 450. So what's the rule this time? To add two numbers with different signs, subtract the sizes, take the larger minus the smaller, and then keep the sign of the number with the larger size. So if we want to find the negative 22 plus 30, we subtract and get 8, and we keep the sign of the larger number here, which is positive. So when we add two numbers with different signs, we subtract the sizes. When we add two numbers with the same sign, we add the sizes. So do two different rules for adding. All right, let's try a couple here. And your book suggests no calculator on these, but can anybody do these for me? How about the first one? Negative 33 plus negative 8. Negative 41. Good, Caressa. And then how about 33 plus 8? What's that going to be? How about that second one? That one's 41. Now we get into the opposite signs. So what are we going to do on this one? Negative 33 plus 8. Good. Very good. Negative 25. Now, how about 33 plus negative 8? Now it's going to become positive 25. Yes. Okay, so you see all the different scenarios here. Same sign being added, opposite signs being added. You actually subtract and keep the sign of the larger number. Good job. Okay, this section also gets into the multiplication, and he tried to show you this with some patterns again. And if you notice, if I take 5 minus 2, I'm sorry, this is not multiplication yet. This is still subtraction. 5 minus 3 is 2. And if I keep going in the same pattern, 5 minus 2 is 3, 5 minus 1 is 4, 5, 6, 7, and 8. And so this kind of shows you that pattern that we're seeing continuing through, and that sort of makes sense then why we come up with 5 minus minus 1 is 6, 5 minus minus 2 is 7. And so again, if we look at the negatives here, negative number is a number less than 0. We indicate a negative number by writing a negative sign in front of it. And again, we talked about this before. Negative is going to be on the left side of 0 on the number line. Absolute value, remember we said, is the distance from 0. All the whole numbers and their opposites are the integers. So to change a subtraction problem into addition. So instead of subtracting, you're going to add the opposite. So for instance, if you want to take 5 minus negative 10, you can change it to an addition problem by adding the opposite of the number. So 5 minus negative 10 becomes 5 plus, and the opposite of negative 10 is plus 10, so this becomes 15. And then negative 5 minus 10, we're going to change it to an addition problem, and we're going to add the opposite. So this time we get negative 15. So this is a very useful rule, because if you're working things by hand, you may forget exactly what to do. But change a subtraction into an addition problem. Instead of subtracting, add the opposite of the second number, the number that you're trying to subtract. So let's try a couple problems here. So this is what we're doing, the same thing, 120 minus 7. So change it into an addition problem. So 120 plus the opposite of 7, which is negative 7. So the answer is, anybody want to try that one? What's the answer going to be on that one? So this is going to become negative 120 plus the opposite of 7, which is negative 7, which is negative 127. Okay? So John, do you see that? You're not going to, remember what we said, we changed it into an addition. I'm going to switch the subtraction to addition, and then I'm going to add the opposite of that second number. Okay? Let's try another one. This one's already written that way, so this one's pretty easy. Now, this time you're adding numbers. This is kind of a mix-up on this page of different rules. You're adding numbers with different signs. So what are you going to do this time? Right, Caressa's got it. When we're adding numbers with different signs, we subtract, and then we take the sign of the larger number. In this case, it's positive. Good. Now, how about this one? This is like the first one. So what are we going to get for an answer here? You're going to change this. This is going to be negative 72 plus, and I'm going to add the opposite. Whoops. Negative 84. Good, John. Now, how about this one? Same thing you're going to do, but it's going to have a different answer this time, isn't it? So it's going to become negative 72 plus, what's the opposite of negative 12? It is 12. So what's your answer going to be here? Good. Yep, negative 60. Great. Because when I got to this point here, I had opposite signs. So what do I do when I'm adding numbers with opposite signs? I subtract and I keep the sign of the larger number. Very good. Oh, can you hear me now? Is it back now, hopefully? Okay. Okay. Sorry. Sometimes it just fades in and out. I have to watch my little, I have a monitor for it. Okay. One more. Fractions. Now think of your rule again. This is a subtraction. So I want to change it into an addition. And I'm going to add the opposite of the sign in the parentheses. Can't hear again? Oh. Testing, testing. Okay, John, can you hear? If John, let me type for him if he can't hear. Let's try again. Caressa, can you still hear? I think it should be coming up. I can see it. I can see the monitor. She can hear. John, can you hear? John, you still there? John, I'm talking now. Can you hear? John? Okay. That's the best advice I can give you. Yeah, that's the best thing to do. Okay, Robin and Caressa, we'll just wait a minute. Sometimes the connection gets lost or something because I know you guys can hear, so let's just wait a minute. There he is. Okay, John, can you hear now? John? Okay, good. Okay. All right, so let's do the fraction one. Great. All right, let's do this fraction one. So remember, it was a subtraction, and so what did I do? I changed it into addition, and I'm adding the opposite of the number in parentheses. All right, so this one's tougher, isn't it? Because you've got, let's see if I can, I'm going to handwrite it because the typing doesn't work so good with fractions. So now I have negative 2/3 plus 1/4. So what do I need to think about now? I need to find an LCD, right? Because to combine the fractions, I need to have the same denominator. And the LCD here is going to be 12, right? Exactly. So how am I going to get this fraction to have a denominator of 12? I need to multiply by, let's see if I can freehand this in here. I'm going to multiply by 4/4, right? 4/4. She's got the answer, you're right. And this one's going to be 3/3. So what do I have? I have negative 8/12 Oh, this is so bad with freehanding here. And then I'm adding 3/12. Okay, now Caressa, be careful. Is it positive or negative though? It's actually, I'm going to type it in here. It's actually -5/12. You want to watch your signs, okay, because this was the larger one, remember? When they're opposite signs, we subtract, and then we keep the sign of the larger number. So it should be -5/12. Okay, that's okay. No, that's fine. I just wanted to make sure that you were seeing it. But 5/12 is right with a negative in front of it. Good job. Okay, let's try a couple more on the next page. So if it's 22 degrees Fahrenheit in the morning, but it rises to 44 by noon, what is the change in the temperature? Not the final temperature, but what's the change in the temperature? So it went from 22, right, to 47, so it went up by 25 degrees. Generalize how you wrote this calculation. So how did you do it? You took the ending minus the starting. If the temperature is 5 degrees below 0 when you wake up, but the temperature rises 26 degrees above 0, what is the change? So now we went from 5 degrees below to 26 above. What's the change this time? 5 below. It's actually 31. She's right. It goes up. It's a total change from -5 up to +26. So the actual change here is 31. And how did we do this one? Oh, here's another one. Sorry. If it is 26 below now, 26 degrees Fahrenheit now, but it drops to 5 below, what's the drop in the temperature? So this was an increase. This is a decrease. So this is the same number, but it's a drop this time. This was a 31% increase. So this was -5 up to +26. This one here was 26 down to -5. So you see the difference in these? This one's a rise. This one's a drop. Okay, Caressa, did you have a question? I think, or maybe you were just typing the answer in. I wasn't sure if you had a question. Oh, okay. Oh, that's weird. Okay. Okay, great. All right. Okay, so what we did so far was we talked about sign, numbers, and absolute value. And then in this section here, we talked about adding and subtracting sign numbers. So the next section is going to talk about multiplying and dividing. So we're going to go back to the golfer again. And so the golfer is 3 strokes over par on each of her first 5 holes. What is her current score relative to par? Include a sign number and also draw this on the number line. So if you were going to draw it on the number line, let me get my pen. Okay, so you start at 0, and then what happened to her? She had +3, +3, +3, +3, +3. Is that 5? 1, 2, 3, 4, 5. Yeah. Okay. So where did she end up? 15 over par. Good. Yep. So her total result was +15. Just like that. Okay. So let's look at some situations here and develop some rules for multiplying and dividing. Since multiplication is repeated addition, we can convert 3 times -4 to an addition problem. So that just means 3 times -4 is simply -4 plus -4 plus -4 or -12. Do the same thing with 4 times -6. So we're just adding -6 4 times. and we get negative 24. So make a conjecture about multiplying a positive number times a negative number. What would be our conjecture? What do we do with the sizes first when we multiply? We multiply the sizes, right, and when the signs are opposite, what do? We get a negative number, right? So we multiply the sizes. 4 times 3 is 12. 6 times 4 is 24. Opposite signs, we're going to end up with a negative answer. So negative times a positive is always going to give us a negative. And then let's look at patterns again. So 3 times negative 7 is negative 21. 2 times negative 7 is negative 14. 1 times negative 7 is negative 7. 0 times anything is 0. Now what's going to happen here? Negative 1 times negative 7. What happens when we have two negatives? What do we get? We get a positive, right? So 7, 14, and 21. So when we're multiplying two numbers with opposite signs, we get a negative answer. When we're multiplying two numbers with the same sign, in this case both negatives, we get a positive number. Okay, so multiplying by two negative numbers, we're going to get a positive. And then we can, if we multiply sign numbers, we can also think about this as division. So one way to think about 24 divided by 3 is, what do I multiply by 3 to get 24? So how can I change this one into a multiplication problem? What do I multiply by 18 to get 36? Now think about this one. What am I multiply by negative 5 to get negative 25? What would be the answer there? So what do I multiply by negative 5 to get negative 25? The answer is, anybody want to try that one? It's 5, yep. And then what do I multiply by negative 6 to get positive 12? What do I multiply by negative 6 to get positive 12? Yeah, it's negative 2, right? Negative 2. And then what do I multiply by 8 to get negative 48? So what times 8 gives me negative 48? And the answer there is, anybody want to try that one? Anybody want to try? No? Okay, this one is negative 6. Okay, because I have a negative number here, so one of the numbers I'm going to multiply here is going to have to be a negative. So this is a negative 6. So let's generalize the results here. So if I multiply a positive times a positive, what do I get? Positive times positive gives me a positive, right? Positive times positive. And what about a negative times a negative? What do I get? Negative times a negative gives me that gives me a positive also. Positive times a negative gives me a negative. Positive times a negative gives me a negative. So notice the pattern here. When the signs of the two numbers are the same, both positive or both negative, I get a positive answer. When their signs are opposite, I get a negative answer. Now what about dividing? Positive divided by a positive gives me a positive. Now how about a positive divided by a negative? I get a negative. A negative divided by a positive gives me a negative, and a negative divided by a negative gives me a positive. So again, notice what's happening here. Same signs, same as multiplication, absolutely. So they're really just opposite operations, but the same rules are going to apply. So to multiply or to divide two numbers with the same sign, we multiply or divide the sizes, and the result is positive. And here's 4 examples for you. To multiply or divide two numbers with different sizes, we multiply or divide the signs, and the result here is negative. And again, 4 examples to show you that. Okay. Now, I've got some fraction problems. Now, this one's going to be harder because this is a subtraction problem. And rather than having you do all the work here, I'm going to put the answer up. But we've got to have at least common denominator, remember, to work on this problem. So it's going to be 8 times 17. And then over here, if you realize what's happening, I'm subtracting. And remember what we said, we can change a subtraction into adding the opposite. Okay, so I get rid of the subtraction on the last step. Whoops, wrong one. And I add the opposite, and so I actually come out with negative 83 over 136. Now how about this one? This one we can just do by looking at it, right? When we're multiplying fractions, we multiply the numerators and we multiply the denominators. Now here we're multiplying two numbers with the same sign, so the answer is going to be positive. And so what are we going to get? We're going to multiply across, whoops, and oh, this came up too. So right across 12, 18 times 17 is 136, and remember, positive times a negative times a negative gives me a positive answer. And this one can actually be reduced. Remember, when you're dividing fractions, we change it to multiplying by the reciprocal, and you keep the sign, and then just go ahead and multiply. And I actually simplified here first. Yeah, I did. I noticed before I multiplied across that 15 divides into 30 twice. And so therefore I had 1 times 11 is 11, 2 times 2 is 4. I'm multiplying numbers with different signs, so the answer is negative. So a couple problems to review your fractions, just in case you forget your fraction rules. You're asked to find a number that squares to 25, which means some number times itself is 25. So what could be the possible answers here? We want to have the same number in parentheses. What are the possible answers? We could have a 5. Is there anything else we could use? Is there any other number times itself that gives me 25? We could have 5 or negative 5, right? Because negative 5 times negative 5 would also give me 25. So if you're asked to find the square root of 25, this symbol means the non-negative answer. So the non-negative answer is just the 5. So when you see this, we call this a radical sign, a square root sign. If it's written like that, it means give me the positive square root. How about if you were asked to find a number whose square is negative 25? Can you do that? Is there a number times itself that gives me negative 25 rather than 25? Is that possible? Anybody want to try that? Is there a number times itself that gives me negative 25? No. Well, there is a number, but it's not a real number. And we're not going to deal with non-real numbers in here. To show to yourself, take your calculator and try to find the square root of negative 9. No, John, negative 5 doesn't work, because if you multiply negative 5 times negative 5, you get positive 25. But on your own, on your calculator, take your calculator and use it to find the square root of negative 9. And you'll get some kind of an error message. It depends on the calculator. I was just checking mine to see what it tells me. My calculator says error, non-real answer. But you're going to get an error because you can't, in the real number system, there is not a number that's the square root of negative 9. So this is not in the real number system. It's in another system, which we're not going to cover in this class. Here's a little summary of the real numbers. So real numbers include all numbers that can be represented on a number line. 0, 3, pi, all these kind of numbers. We have counting numbers. We have whole numbers. We have integers. We have rational numbers that can be written as the quotient of two integers. We have irrational numbers that cannot be written as the quotient of two integers, things like square root of 5 and pi. And then the square roots of negative numbers are a set of numbers called imaginary numbers, which again, we won't cover in this class, but there is a set of numbers to deal with. The example I just had, what's the square root of negative 25? It's just not a real number. So here's a nice summary of all the kinds of real numbers. Okay, one last section to do today. And this is your first introduction to statistics. And in this section, we're going to do means. So a student is taking a math class that has 5 exams, and each one is worth 100 points. After 4 exams, her average for the course is 80%. She tells her friend, if I get 100 on the last exam, my grade will be an A. 80 and 100 average to be a 90, which is an A. Her friend replies that it's not even possible for you to get an A in this class. Who's right? Why? Okay. So the friend is right. And why is that? Because the 80% that the student had was the average of the 4 exams. And they were each worth 100 points. So that means she only earned 80% of the 400 points possible, or 320 points. To get an A in the class, she would have to have 90% of 500 points on the 5 exams, or 450 points. So she can't get an A. It's not possible, because the exams are only worth 100 points. So we want to be careful on how we apply the concept of taking an average. So the average or the mean of a set of numbers is one measure of the data's center or middle. To find the mean, we add all the numbers up and divide by the number of observations. And if you think about it graphically, the mean is kind of the balancing point of the numbers in the data set. And here's a little picture with bars on a graph that might help you see it. But we call that the average. So for this price of meals, the average is $34. So John spent $24, $38, and $40. And if we add those 3 up and divide by 3, the average price per meal was $34. And again, it's called the balancing point if you want to think about it. The distance from each of those points, the distance here, 10 units, is balanced by the distance over here of 4 plus 6 or 10. So it's the balancing point. All right, there's a couple problems here. Let me see. Let me go through. I'm going to skip to the next slide. When I do this in class, the students work on these in groups. But let's take a look. So here's your scores on 3 quizzes, let's say. So what's your average? So what's your average going to be? You're going to add these up and divide by 3. So 8 plus 8 is 16, plus 5 is 21. So 21 divided by 3 gives me an average of 7. Okay. Your friend's average is the same as yours, but she earned the same score on each quiz. So what are her quiz scores? She got the same thing on each of them, so she got a 7 and a 7 and a 7. Okay, let's try another one. On the 4th quiz, you earned 3 out of 10. So here was your first 3 scores. And then you took your 4th quiz and you got a 4. So what's your average now? So remember, average is, we're going to add them all up, 8 plus 8 plus 5 plus 4, and we're going to divide by 4. And what do we have? 16, 21, so 25 divided by 4. That's not right, is it? 24, I'm sorry. Oh, this is a 3. My mistake here. Let me go back for a minute. This is a 3. There he is, 24. 24 divided by 4 gives me a 6. Okay, I made a mistake here. This is a 3. There we are. Yeah, on the 4th quiz, you earned 3 out of 10. And let's average the 4 now. So I added them up. 8 plus 8 plus 5 plus 3 gives me 24 over 4, or an average of 6. How many points lower is your average after test 4 compared to your average after test 3? So when you had 3 of them, your score was a 7. And after 4, your score was a 6. End minus start divided by start. So end was 6 minus 7 divided by 7%, change. So you dropped about 14% from after quiz 3 to after quiz 4. Not doing so good. Okay, not good. Yeah, not good at all. All right, so let's see what's going to happen now. You're unhappy with your current average and you decide you want to raise the average to a C. So you want to get back up to a C, which is a 7. If the 5th quiz is also worth 10 points, what score do you need to bring your average back to the C range? Okay, so remember, right now you have 24 points. Remember? You had 24 points earned. To get the C, with adding the 5th quiz in, you need how many points? 7 times 5, or 35 points. You need 11 points on the last quiz. And we can check this, right? Because we could say, okay, here's the score I said I needed. Let's find the average of those 5, and it comes out to be a 7. Checks. All right. Is this possible? Can you get 11? If the instructor offered a bonus point, would it be possible? Well, if there was a bonus, yes. Is it likely? You think it's likely that this student is going to get back up to a C? Probably not, given your other test scores. Remember, your other test scores were what? 8, 8, 5, 3. Seems like you're on a downward trend, so it doesn't look too good for this student. And then let's get back to that balancing point idea. So if you had a 7 on the balance point, so if you think about this, let's see if I can, yeah, I don't have a picture of it, so let's see if I can sketch it for you. So basically what you're saying is, here's your balance point. So you have a 7, and then what did you have? You had an 8, and an 8, and you had a 5. So if you think about it this way, by the balance point, I probably should have done it the other way. Let me go back. I should put the 8s on the top. So you have an 8, and an 8, and then you have a 5. Whoops. So if you think about this from the balance point idea, these two are 1 point above the mean. This is 2 points below the mean, so this is like a -2, and it's being balanced out by a +1 and a +1. That's what we mean by the balance point idea. Suppose you have 60% of 100 points in the course so far. If you get 90 points out of 100 on your next test, what is your average? So you'll have 60% of 100 so far, and then you get a 90. Notice these were equally weighted, right? So you could just take the average of these two. So what's your average now? It's going to be 75%. Because again, look at the weighting here. They're exactly the same number of points. Remember the original problem we started with? There were 4 tests worth 400 points. These are equal, so we can just average those two. Suppose you have, now here's the difference. You have 60% of 900 points. If you get 90 points out of 100 on your next test, what is your average? Okay, this one's different, isn't it? Because you've got 60%. Let's go ahead and, let me go over to another whiteboard because I'm going to run out of, oh no, I can do it down here. I have space over here. So let's see, how many points have you earned so far? You've got 0.6 times 900, which means you have 540 points, right? And then you got 90 points. So we've got that. So now you've got 90 points. So if I add those two together, 540 plus 90 gives me, plus 90 equals 630 out of how many total points? 1,000, right? So what's your score now? 63%. So these two problems are shown to show you the difference between, these were equally weighted, so I was actually able to just average the two scores. Here, there's a lot more weight here, 900 versus 100. So I actually had to figure out the total points earned to figure out what the student's score was so far. So this 90% on that next test brought up the score, but it only brought it up a little bit. Here, the 90% really brought the score up a lot because, again, equal weighting on those two. So hopefully that makes sense in terms of how you look at your grade in a class. Okay, so that's the end of the material for today. So this section here, you're learning about sign numbers, absolute value, adding, subtracting, multiply, dividing sign numbers, and then your first introduction to statistics with means in section 2.5. So anybody have questions on things? I don't know if you've looked at your homework yet, but any questions on things that we went over today? Okay, you're welcome, Caressa. Okay, great. Robin, are you okay? Oh, John, sure, I'm in my office. Do you have my office phone number? Sure. Oops. 727-341-4312. Okay, great. Okay, I'm going to log off if everybody's good with this, and we'll have a chat again next week. Oops. Okay, have a good week, everybody.